So number 11 could be fun. Could be a little challenge. So we're going to try and take this through step by step. You could change this in terms of sines and cosines. Absolutely nothing wrong with that. I'm not going to. Why? Because you may have tried this using sines and cosines and got stuck and got frustrated. Sometimes I like to show you, I don't know, little tricks, and you kind of pick them up. The more you do it, the more you kind of see these tricks. Going back to our Pythagorean identities. So we know our sine squared plus cosine squared equals 1. The other one that we have 3, remember. Another one that we have is tangent squared x plus 1 is equal to secant squared x. So when I'm looking at this, I see tangent squared x, and I immediately think, okay, well, I know tangent squared x is equal to secant squared x minus 1, because I have that theorem in my head. I have that memorized. So I'm going to take this left-hand side, and I'm going to replace that with secant squared x minus 1. Okay, now we can expand this numerator. So I can write this so that it's looking like secant x minus 1, secant x plus 1, all over secant of x plus 1. Okay, I have common terms here. These terms reduce out, and so now we're left with secant of x minus 1. Don't panic, because we know that this has to look like that. We're going to get there. How about now we turn it into sines and cosines? So I know secant is 1 over cosine. I know 1 is 1. But if I want to combine these things, they're going to have common denominators. So I'm going to write 1 as cosine over cosine. Still 1, just looks different. Okay, so now I can combine. So I have 1 minus cosine for my numerator. For my denominator, cosine. And that's your answer. Kind of came a little bit faster than you realized. Once you got here, it looks weird. What do? You just got to be careful with your fractions. Okay, that was number 11.